Hey class, welcome back. If you check out the board behind me, we're going to go through the week 22 notes. Today's video lesson might be a tiny bit longer than usual. Remember, we have next week off, and I want to make sure that we go through some of the things that we'll be checking out as we move into the last couple of weeks of school, whether we're in-person learning or where there's continuing distance learning. There's a lot to cover, and I would argue that this is probably one of the more important lectures in terms of one of the things that we're going to get into. Dr. Guccione, our guest lecturer earlier this week, talked a little bit about it, and that is vaccines. So we're going to cover a lot of ground here, and the takeaway is this. One, at the very beginning, I'm going to point out the key terms for when we come back. The key terms are really body systems, and two, one of the things that we need to understand, at least at a high level, is how the immune system works, particularly when we're talking about COVID-19 and where vaccines come into play when we're talking about protecting ourselves when we get back to school. So here we go, let's jump on in. If you look at vaccines and immunity, first of all, a quick review. One of the things I wanted to review with us all is some former key terms that we had. So I'm going to go a little bit slower because there's a lot of information on the boards here. Often when I'm talking about these things with the class, I'll say, well, there's two boards and it's really not that difficult. I am going to be completely honest. This is a difficult subject when you're talking about vaccines and how they work. So we're going for the high level overview and really trying to hit the key points. So let's jump back on in here. If you look at our body systems, usually it's divided up into about 11 systems. And the 11 systems are written here. I'll again write up these notes and take a picture of the board and put them out there. These 11 systems will be the key terms when we return for week 23. And by key terms, I would like the students using the textbook or of course using the internet and a good old-fashioned encyclopedia, a sentence about what does each system do. Now we're focusing, that's why there's a little star next to this one here, we're focusing on the immune system. We got to remember, like in the case of COVID-19, it's a good example. While we're focusing on the immune system, something like COVID-19 can affect almost every system. So that's really important to kind of keep in mind that the systems work together. If you think about, for example, cars. Back in the old days at Cappuccino High School, we used to have auto shop, and one of the things, I don't know if they still have auto shop in high school, I hope they do, but one of the things that they used to talk about was the systems in cars, the braking system, the cooling system. If you look at the systems of a car, you can break apart a car into these separate systems to understand it, but a problem with one system can affect or even stop the entire car. It's a little bit like that. Our systems, yeah, we break the body so that we can understand it better into these 11 systems, but a problem with one system can certainly affect every other system. So that's really important to kind of keep in mind. Usually we'd have a little bit more time to go into detail on some of the systems we are particularly talking about the immune system right now because, of course, vaccines and COVID-19. The immune system and viruses is what we're hitting right now. And the immune system compared to the other 10 is a little bit different. While most of the other 10 systems, for example, the digestive system, you might talk about your liver, your spleen, your large and small intestine, your stomach. The immune system's a little different. It's not like a traditional tissue organ system. Instead, you can kind of think about it, and I use it throughout this lecture, the Pacifica Police Department. You can kind of think about it as roving bands of cells, or in this case, the Pacifica Police Department. Certainly they have a main police station, but the police are around town all the time, protecting citizens. That's the job of our immune system. And if you look at the immune system, I'm going to break the immune system into two parts. Normally we'd study this part first and then talk about the acquired or adaptive immune system. Kind of flipping it here, it doesn't really matter. But the first part of the immune system is kind of considered the first layer of defense. And if, look at the notes here, right here. You can think of it as kind of like being on patrol. This is the immune system that acts a little bit like the walls of a walled city. Think about your social studies classes when they had wall cities and the walls are there to protect against invaders. That's what this part of the system do. It's not specific for a pathogen. A pathogen is going to be also one of our words. It has been one of our words before. A pathogen is something that can cause disease. It's not specific to a certain pathogen. Instead, it is a general system that is designed to keep out invaders. The most basic part you can obviously think of it as like skin and mucous membranes. They're there to keep pathogens from getting into your body and causing problems. If something gets through there, there are other cells that will go and cause inflammation, which can be a good thing because it's alerting your adaptive immune system, which we'll talk about in a second, to send in specific antibodies. We'll get into those words in a sec, but specific immune responses to go after certain invaders. But the long and the short of it is the first part of the immune system is kind of passive. It's a little bit like why we're wearing masks right now. I was looking for my mask over here. Why we're wearing these around town right now. It's aiding in the prevention of spreading around COVID. Why? The very first thing that we can do is stop a virus or other pathogen from getting into our bodies. And by using masks and keeping droplets that we are either exhaling or inhaling, we can slow down the spread of COVID-19. So that's very, very, very important. Moving on to specifically COVID-19. While the first part of our immune system, our innate immune system, is like the walls, the barriers to keep things from getting in, what if something does get in, a pathogen like a virus, like COVID-19, that can then, of course, invade cells, make duplicates of itself, and cause problems for all the other 10 systems in the body? Well, let's check it out. You can think of our adaptive immune system. Pacifica's elite squad of highly trained officers. In other words, they are there to recognize a specific type of pathogen. Think about flu. We're going to compare COVID-19 here in a second to the flu. It's a little bit like the PPD, the Pacifica Police Department, keeping a file on a criminal that has been in town. Someone has come in town, they broke into a car, we caught him. The Pacifica Police Department keeps a file, a mugshot, a picture of that person, and they know if this person comes into town again, to look for them because this was a previous pathogen, a previous troublemaker in the town. Well, again, I'm going to use this police department analogy a couple times. I hope you don't mind. It is a little bit like looking for a very specific molecule that comes into our bodies. What does it do? Our adaptive immune system recognizes it, kind of like the police force looking at a picture. It recognizes it as a foreign molecule, and it produces antibodies. Now, if you check out the underlined word antibodies, they are specific molecules that hold on to, if you can think of it as holding on to, a virus or other pathogen. And as it holds on, it's like grabbing onto it, saying, okay, you're not going anywhere. And it calls in other cells in our immune system that then consume the pathogen. So our adaptive immune system does this. It keeps a file, if you will, on a specific type of pathogen. When it recognizes that pathogen, it has antibodies that literally hold on to it, while macrophages, big eaters in our immune system, come along and eat it. One of the things about vaccines that make them so completely awesome is that what we can do now is introduce, and this is how vaccines work, all the way going back to smallpox and cowpox. We introduce a dead or a weakened form of a virus into a body, and then your immune system, our immune system, creates antibodies for that specific virus. When it sees it again, it'll say, hey, wait a second, I've seen this before. I know about this specific one. And it immediately doesn't have to spend a lot of time ramping up an immune response. Instead, it already has, by it, I mean our immune system already has antibodies ready to go. They latch onto the virus, and they call in the macrophages, which are big eaters. They come on into these cells that engulf things and eat them, much like we saw many chapters ago how amoebas come in and eat a cell. They engulf the cell. It's a little bit what a macrophage does. So vaccines have saved literally millions of lives once they figured out that you could take a weakened form of a virus or a dead form of a virus, introduce it to a body. Your body would make antibodies, our immune system would make antibodies for it, and the antibodies would then latch on, hold on to that virus or pathogen until the rest of the body can send out macrophages and eat it. Kind of a simplified version there, but if you check out, yep, we're going to board 3 here. If you check out some of the things that vaccinations have saved us from over the years, you're looking at things like polio, smallpox, measles, and whooping cough. Not a small thing. I've included measles up here for a specific reason. Measles has kind of made a resurgence lately, and we're going to talk a little bit about that because of people not getting vaccinated against it. Measles, you can kind of think of it as, a lot of people think of it as like, oh, well, it's an annoying childhood disease if somebody gets it with a breakout and stuff like that. No, there can actually be some very serious side effects to measles. For example, if you look at encephalitis, it's brain swelling. If you look at high fevers, there's a lot of problems that go along with measles, particularly for the very young or people who get it when they're elderly. And measles, something that should have been completely eradicated, completely wiped out, actually made a resurgence the last couple of years because of people not getting vaccinated. Smallpox, another one that was actually completely eliminated through vaccinations. Very, very important. Polio, if you lived 100 years ago, polio was a huge disease to be scared of. Again, vaccinations have taken care of polio in the United States, which is fantastic. And we're going to talk a little bit about vaccinations and why some people have not been getting vaccinated. So let's go into here. If you look at the police analogy, if the police had a file on a particular pathogen, on a particular criminal that was coming on into town, let's just say he or she, the pathogen, the criminal that had previously come into Pacifica, say taken a surfboard off somebody's car and run off with it. Let's just say, for example, they changed their appearance. They changed their name and appearance. That is analogous to a virus or a pathogen mutating. Remember, we've talked about mutations, random changes in DNA. In the case of COVID-19, it's an RNA virus, and we know that mutations happen at a regular rate. This is how viruses survive. This is how viruses adapt. And it's almost, you can think of it like their job. They have to mutate and change their DNA to constantly try and get around the body's police force. If you look at the optional extra credit, remember this is what a lot of the students are interested in, optional extra credit due at the end of next week, at the end of our vacation week. But of course you have this week to work on it. It is straight out of our textbook, pages 143, and it talks about this specific question. Questions 1 through 8 on page 143. One of the questions is, why do we have to have a new flu shot every year? For example, last October I got a flu shot. Hey, this October I got a flu shot again. Why? I thought immunity was supposed to last. Remember, in the case of the flu virus and other viruses too, one of the things they're very good at doing is changing their DNA, changing their RNA through mutations. And when they do that, our body's police force can't recognize it. You might remember Dr. Guccione talked about the variants in the COVID-19 virus that are going around. There's the UK variant, I believe the Brazilian variant, a couple of others. Those are the things that immunologists, the people who study vaccines, really worry about when we're trying to get the vaccine rolled out as quick as possible. Why? Because as soon as a virus mutates past a certain point, our vaccines might not work on it as well or might not work on it at all. So we're always trying to stay one step ahead of the mutations that the viruses have. Finally, the last little part right here, a couple things on why people might not sometimes trust vaccinations, which gets to be somewhat frustrating sometimes. If you check out, first of all, side effects. Every once in a while, MMR, for example, measles, mumps, rubella, these are one of the vaccinations that everyone gets. You have to get them, of course, to attend school. About 1 in 3,000 kids who get this have a bit of a reaction to it, sometimes seizures. That sounds terrible, seizures. These are not long-lasting or long-term dangerous effects, but it is one of those things that definitely people hear about, oh, seizures, that might not be good, this vaccine can't be good for you. No, the vaccine over the course of the time that we've been using it, since the 1950s, has saved literally millions of lives. Yes, there are some people who have a reaction, but those are short-term reactions. Usually, they go away quite quickly, and that's why they often, after they give you a vaccine, say, okay, stick around the doctor's office for a few minutes, and just to make sure that you're not one of those 1 in 3,000 that might have a reaction to it. There was, for example, in the case of autism, whether or not you're familiar with autism, there was a doctor by the name of Andrew Wakefield. He's not a doctor anymore. He actually lost his right to practice medicine in the UK. The point is, he put out a guess. He put out basically an uninformed guess that I wonder if there's a connection between vaccines and autism. Because around the same time a person gets a lot of vaccines when they're young, that's also around the same time that you start to notice autism symptoms. This is one of those times where coincidence does not mean that one causes the other. As a matter of fact, since Dr. Wakefield, the former Dr. Wakefield, came out with this idea, studies have shown that there is no connection at all between childhood vaccines and autism. The problem is this. Nowadays, we live in a media-saturated environment. You're on YouTube if you're watching this right now. I'll obviously send this out to our Google Classrooms. But look at all the things on the site on YouTube. You can click on just about anything, and almost anyone can put out really any video they want. And if you look at this right here, a person put out what seemed like a quick, easy answer to a very difficult problem to solve. Why do some children exhibit signs of autism? He threw out this idea, well, maybe vaccines, and a lot of people jumped on that. Yeah, that must be it. It's easy to go for the quick answer. While the science studies lagged behind, it took a year or two before science studies came on and said, no, there is no connection. By then, it already gains traction in the media. It's really difficult to fight that sort of thing. Also, disinformation and misinformation. There are a lot of people out there who put out uninformed opinions. For example, very recently, there was the most recent president we had about a year ago came out and said, well, I didn't get my kids vaccinated all at once because look at all the stuff that they're giving them in a short amount of time. That's just too much for them. There's no evidence at all to support that giving vaccines in a short amount of time versus spacing it out makes any real difference, yet it's one of those things that in the media gains a lot of traction. It's one of the reasons we have this science class, to come to grips with all the misinformation out there. There is a lot of it. Also, the side effect thing. The side effect thing is a little bit like comparing it to airplane crashes. I know that sounds like a harsh analogy, but bear with me for just a second. Anytime there's an airplane mishap in the United States, or anywhere in the world really, obviously it makes the news. It's a big deal. And yes, it's a scary thing if an airplane crashes or goes down somewhere. But an airplane crash, an airplane incident, is extraordinarily rare. The precautions and the safety of flying is well established. Not to hit you with a harsh statistic, but roughly in the United States, 40,000 people. That's a stadium, San Francisco Giants Stadium full of people, 40,000 people die every year in car accidents. Every single day, we don't have a big listing on the news of all the people who died in a car accident, yet 40,000 people a year are dying in car accidents. Again, it is what is paid attention to, and one of the very difficult things is those very rare reactions to a vaccine that some people might have, which we already talked about. Usually, you get over them right away if somebody has a seizure with one. That makes the news. More specifically, when I brought up this computer to make this video just a few minutes ago, the thing that popped up on the news was one person having a bad reaction to the COVID-19 vaccine. Yes, that does happen, but looking at things overall, vaccines are incredibly effective. They've saved millions of lives, and some of the side effects that you hear about, yes, they are real things. But when you're looking at it in terms of the number of lives saved by vaccines over the last 3/4 of a century, you're looking at quite literally about 60% of the people watching this video right now having avoided a major illness because of vaccines. And finally, one thing that gave vaccines a really bad rap and I'll go into this in more detail on the online notes, was a bad batch of polio vaccines that went out in 1955. That did cause, unfortunately, paralysis, and it did cause sickness in several dozen young kids who got the vaccine. That a tragic event, yet it gave the polio vaccine sort of a bad reputation at the time. So if you're looking at vaccines, there's a lot of anecdotal evidence. Well, I don't know if I should get this vaccine. Is it safe? Overwhelmingly, vaccines are not only safe, but they've literally saved millions of lives in this country and around the world. And when we're studying the immune response, the reason vaccines work is because our bodies are able to recognize a pathogen, and they're able to ramp up antibodies to latch on to that pathogen, to latch on to that disease-causing agent, thereby calling in all these other cells, macrophages and other cells that then eat it. Kind of a simplified version of it, but that's basically what's going on with the vaccine. Take care of yourself, and I will see you when we get back the next week. We've got a week off after Thursday, Friday, and then we'll be back here for week 23. Take care. Bye-bye.